Let's look at the electron configuration of sodium. First, we need to look at our periodic table and find sodium. Sodium has atomic number 11. Sodium has an atomic number of 11, so we need 11 electrons in our electron configuration. Using the periodic table set up in blocks, we find that sodium is right here. So when we start to write the expanded notation, we start with the 1s and put 2 electrons in the 1s orbital. So we write 1s2. We're up to 2 electrons, we need 9 more. We move down a row, we fill the 2s orbital, so we write 2s2. We're up to 4 electrons. We can fill the 2p orbital with 6 electrons, so we write 2p6. We have 10 electrons so far. We need to add 1 more. Here's sodium on the periodic table, so we write 3s1. We can go back and see how many electrons we put in by counting the superscripts. We have 2, 4, 10, 11 electrons. The superscripts tell us the number of electrons in each subshell, and if you count them, you'll figure out how many electrons you have. So in the noble gas configuration, we move from sodium's place on the periodic table, we move up a row and all the way over to find the nearest noble gas. And for this, it's neon. So neon takes the place of 1s2, 2s2, 2p6. We put neon in brackets, and then whatever's left we write next to it. So the noble gas configuration is neon 3s1. Again, to find the noble gas, we look at sodium, move up a row, and all the way over to find neon. And neon has 10 electrons, which is represented here as 1s2, 2s2, 2p6. So we write neon 3s1. We can also find the valence shell electrons, and the valence shell is the highest value of n. And if we look at our expanded notation, the highest value of n is n equals 3. So our third shell is our valence shell. We count the number of electrons in that shell, and we only have 1 electron in the n equals 3 shell, so we have 1 valence electron.